Hello and welcome students. My name is Dr. Grade12 from BM Virtual Academy. This is Grade 12 Chemistry Lesson 1 from Unit 1. Our content from Unit 1 is focusing on 3 points. The first content is acid-base concepts. So this concept is described by 3 different theories. The second content is focusing on the strengths of acids and bases. So depending upon the dissociation of hydrogen ion and hydroxide ion, we classify this strengths is strong acid, weak acid, a strong base, weak base. Based on this term is generally what we call the strengths of acid and base. The third content is focusing on dissociation constants. So when you understand these terms, you easily identify whether the acid or the base is strong or weak. These are the contents what we learned so far. Good. Now let us come to our lesson. Our lesson from the very beginning, the content was and to understand the concept of acids based on different theories. The first theory is what we call Arrhenius concept. So how can we define acid based on this theory? Acids are substances that increase the concentration of proton ion. Most of the time these protons are H+. So this is the concept of acid according to this theory. Example, now there is an hydrochloric acid here. So HCl, there is proton H+. So when we dissolve this HCl in water, it dissociates into H+ and Cl-. Dear students, as you can see here, there is production of H+. This H+ is what we call proton according to Arrhenius concept. Okay. In the other case, how can we define base based on Arrhenius concept? Now, acids produce H+ or proton. In this case, bases produce hydroxide ion or OH-. So when OH- is produced from sodium or active metals react with water, most of the time always bases are produced. So in this solution there is hydroxide ion. So the production of hydroxide ion in this reaction is represented by Arrhenius concept. So we can say that in general, bases are a substance that increase the concentration of hydroxide ion. So these are the terms of acid and base based on Arrhenius concept. So there are a number of bases, so you can observe this. Okay, as an example, this is sodium hydroxide, first base. So there is OH-. And in the same manner, when the rest hydroxide compounds dissolved in water, always OH- is produced. So this is the concept that directly defined by Arrhenius. So this is the first concept. The second concept is Bronsted-Lowry concept. The concept is completely different from that of Arrhenius. So how can we define acid based on this Bronsted-Lowry concept? Acid is a hydrogen ion donor. A hydrogen ion donor. This is what we call Bronsted-Lowry concept. As you can see here, there is water here. Okay. So according to the hydrogen from the Bronsted-Lowry concept, acid is hydrogen donor. So for whom this hydrogen ion is going to be donated for base? This is the concept of Bronsted-Lowry. The second concept is base. How can we define base based on Bronsted-Lowry concept? As you can see here, ammonia is a good example of base. So base is a hydrogen ion acceptor. From where it accepts, ከየት ነው ይሄ ቤዝ ከሆነ ከየት ነው ሃይድሮጅን አዮኑን የሚቀበል? ከአሲድ። ይሄ ምን ይባላል? Bronsted-Lowry ኮንሴፕት ይባላል ማለት ነው። ስለዚህ Bronsted-Lowry ኮንሴፕት አሲድ ማለት ሃይድሮጅን አዮን ዶነር ሲሆን ቤዝ ማለት ደግሞ ሃይድሮጅን አዮን አክሴፕተር ማለት ነው። ስለዚህ በግልጽ እዚህ ጋር ሪአክሽኑ ላይ እንደምታዩት መጀመሪያ ቤዝ አለ፣ ዜን እዚህ ቤዝ ከሆነ አሞኒያ፣ ሁለተኛው ሪአክታንት ላይ ወተር ነው፣ ኢት አክት አስ አን አሲድ። ስለዚህ አንደኛው ዶነር ነው፣ አንደኛው አክሴፕተር ነው ማለት ነው። በዚህ ተርም ዲፋይን የምናደርገው Bronsted-Lowry ኮንሴፕት ይባላል። The other important concept within the Bronsted-Lowry theory is conjugated acid-base pair. ምን ማለት ነው? Conjugated acid is a particle formed when base gains of hydrogen ion. ማለት ነው። እዚህ ጋር እንደምታዩት መጀመሪያው water አለ። water react with hydrochloric acid yields hydronium ion and chloride ion። እዚህ ጋር እንደምታዩት ሃይድሮክሎሪክ አሲድ ማለት አሲድ ነው። ይሄ አሲድ ከቤዝ ጋር ሪያክት ያደርጋል። ወተር የዚህ ሮል ወተር እንደ ቤዝ ነው የሚያገለግለው። መጨረሻ ላይ ይሄ ወተር ስሩ ኦክሲጅን አንድ ፕሮቶን ከሃይድሮክሎሪክ አሲድ አክሴፕት ካደረገ በኋላ ከተቀበለ በኋላ H3O+ ይሆናል። ስለዚህ መጀመሪያ ቤዝ የነበረው አሲድ ይሆናል ፕሮቶን ከተቀበለ በኋላ። ፕሮቶን ከሰጠ በኋላ ደግሞ ኮንጁጌትድ ቤዝ ይሆናል ማለት ነው። ይሄ ተርም ምን ይባላል? ኮንጁጌትድ አሲድ ኤንድ ቤዝ ፔር ይባላል። ምሳሌዎቹ አሉ፣ ሌሎችም ከታች ያሉትን ማየት ይቻላል። ይሄ ጄነራል አንደርስታንዲንግ ተርሚኖሎጂ ነው። ስለዚህ በቀላሉ መረዳት ይቻላል ማለት ነው። ይሄ ተርም ኮንጁጌትድ አሲድ ኤንድ ቤዝ ፔር ይባላል። ሶስተኛው ኮንሴፕት ከአሪኔስ ኮንሴፕት እና ብሮንስቲል-ሎሪ ኮንሴፕት ቀጥለን የምናገኘው ኮንሴፕት ሉዊስ ኮንሴፕት ነው። So how can we define acids based on this concept? Acids are electron acceptors while bases are electron donor. So acid electron acceptor ነው ስንል ከማን ነው የሚቀበለው? ከቤዝ። ቤዝ ደግሞ ኤሌክትሮን ዶነር ነው ስንል ለማን ነው የሚሰጠው? ዶነር ማለት ሰጪ ማለት ነው። ለማን ነው የሚሰጠው? ለአሲድ። ይህ አይነት ግንኙነት ምን ይባላል? ሉዊስ አሲድ ኤንድ ቤዝ ኮንሴፕት ይባላል ማለት ነው። ስለዚህ እዚህ ጋር ስታዩት ሉዊስ አሲድ ነው፣ ኤሌክትሮን አክሴፕተር ነው። በተቃራኒው ደግሞ እዚህ ጋር ስታዩ ደግሞ ኤሌክትሮን ዶነር። ኤሌክትሮን ዶነር ስንል ለቤዝ ለአሲድ ይሰጣል። ኤሌክትሮን አክሴፕተር ስንል ደግሞ ከቤዝ ይቀበላል ማለት ነው። ይሄ ኮንሴፕት ሉዊስ ኮንሴፕት ይባላል። ስለዚህ አሲድን እና ቤዝን በተለያዩ ኮንሴፕቶች አየን። ስለዚህ ውድ ተማሪዎች እናንተ ምን ማድረግ ያለባችሁ? ሶስት አይነት ኮንሴፕቶች አሉ። አሪኔስ ኮንሴፕት፣ ብሮንስቲል-ሎሪ ኮንሴፕት እና ሉዊስ ኮንሴፕት። የእያንዳንዳቸውን ኮንሴፕት ትርጓሜ ወይም ልዩነት ማወቅ ያስፈልጋል ማለት ነው። ይሄ ጠቅለል ባለ ኮንሴፕትስ ኦፍ አሲድ ኤንድ ቤዝ በሚለው በዚሁ ማጠቃለል ይቻላል ማለት ነው። በጣም ጥሩ። So this is the summary of the concepts in general. So as you can see from this table, what is the main difference between these three different concepts and how can we define acid and base based on these three different concepts? እዚህ ጋር እንደምታዩት አሪኔስ ማለት H+ ፕሮዲውሰር ነው። ቤዝ ማለት ደግሞ OH ፕሮዲውሰር ነው። ብሮንስቲል-ሎሪ ኮንሴፕት ላይ የመጣን እንደሆነ አሲድን now acids are hydrogen ion donor while bases are hydrogen ion acceptor. This is the concept of Bronsted-Lowry. The third one is Lewis concept. According to Lewis concept, acids are electron pair acceptor while bases are electron pair donor. For whom it donates? For acid. Okay, so these are the summary and the whole concepts regarding to acid and base. The second point is ionization or dissociation constants in general. So these dissociation constants are beginning from water. You know that water has both acid and base properties. Why we said water has acid properties? Because it produces hydrogen ion. Why water has base properties? Because it produces hydroxide ion. As a result, such kind of reaction in general is what you call ionization of water or self-ionization of water. Okay? So this is the way how hydrogen ion and hydroxide ions are produced from water molecule, as you can see. Okay. The other important term in this concept is amphoteric species. Amphoteric means both acid and base behavior. So molecules or ion that can either donate or accept a proton. According to Lewis concept, acids are proton donor while bases are electron acceptors. Okay, so depending upon the type of the reaction, amphoteric species in one way in the acid, in the other way in the base. As you can see from this example, this is the reaction between ammonia and water. So this ammonia is base and this is water. So initially ammonia, this is ammonia NH3. After accepting proton from water, it acts as an acid. It becomes acid. As a result, this base and these acids are conjugate base acid base pair based on the Bronsted-Lowry concepts. The second example, the reaction between this acid and this base. Okay, this is acetic acid and this one is water. So the role of water in this case is base, and this acetic acid is act as an acid. Okay, so by donating and accepting the protons, we can say that properties is what we call amphoteric properties, or the species is what we call amphoteric species. Okay, now let me ask some important questions on this, based on this understanding. Do you think that molecule or anion can be both donor or acceptor of proton? This question is for you, so just think and give the answer. እስኪ ይሄንን እያስታወሳችሁ ትቆያላችሁ። Okay, the second point is equilibrium constant. In the ionization of water የአሲድን የቤዝን ባህሪ ይዛልና ነገር ግን ባህሪውን ለመግለጽ ወደ ማትማቲካል ኢኩዌሽን እንመጣለን። Okay, equilibrium constant. That means concentration. So how can we define the concentration of water from its self-reactions? As I said before, from water H plus and OH minus is produced. So at room temperature or near to 25 degrees Celsius, always the equilibrium constant expression for this water is the concentration of the product over the concentration of the reactant air. Our reactant is pure liquid water and our products are H plus and OH minus. But the concentration of pure liquid is always close to 1 unity. Finally, the ionization constant or equilibrium constant for water is symbolized by Kw becomes the products of H plus and OH minus. So at 25 degrees Celsius, the products of this concentration OH minus and H plus gives 1 times 10 to the power of minus 7 molar. Based on this understanding, there is an important example. What is the concentration of H plus in a solution of 0.1 molar sodium hydroxide? Don't forget that, students. Always in base, why we said base dissolved in water produce hydroxide ion. So based on this formula, you can come up with the result of H plus concentration based on this formula. Of course, this one is a solution, so try it by yourself. Okay, the other important term in the ionization of terms is pH scale. pH scale is the scale that used to describe the strength of an acid. Generally, between 0 and 14 in general is pH scale. So when we increase the pH value from here 0 up to 7 is the neutral position in general. So between 7 and 0 is acid range. So as an example, there are a number of species. For example, if you take coffee or tomato, whatever it is, that are found in the acid range, while between 7 and 14 is base, or what you call alkaline. Sometimes the term alkaline and base are the same. Therefore, when the pH value is higher than 7, you can say that this range is base range. If the pH scale is near to 7, that particular base is weak. If the pH scale is near to 7, the name of the acid is weak acid. So near to 0 and higher than 7, that means near to 14, the strength of the base, for example, near to 14 is a strong base, and this range is weak acid. So this is the way how we calculate pH from the given hydrogen ion concentration and from the given hydroxide ion concentration. So in general, in the pH scale, there is a formula to deliver pH from negative logarithm of hydrogen ion concentration if it is an acid, and pOH is equal to the negative logarithm of OH minus if it is a base. So finally, after calculating this value, we can say that this one is an acid and this one is base based on this pH scale. So in general, pH scale is used to identify whether this species is acid or base. These are some of the examples. So from this example, in order to understand the pH of that juice, always the concentration is 5 times 10 to the power of minus 3 molar. So from the given concentration, how can you deliver pH? So based on the formula, based on the negative logarithm of hydrogen ion concentration and based on the negative logarithm of hydroxide ion concentration, you can deliver the pH or calculate pH. But one important point, The summation of pH and pOH is always 14 at 25 degrees Celsius. So don't forget that the summation of these two pHs are always equal with 40. Don't forget, at 25 degrees Celsius. Good. The other important point is measurements of strengths of acid and base. How can we define strengths? The strength means to identify whether the acid is either strong or weak, and if the base is either strong or weak, based on pH scale. So this term in general is what we call the strengths of acid and base. Strengths of acid and base. Okay, in order to understand these terms, there are 4 important points. The first one, concentration of hydrogen and hydroxide ion. So by observing this, we can say that this is strong or weak base. The second one is pH and pOH. This one is also the second point to identify the strength of the acid. And the third one is percent dissociation. This one is also the point to identify whether the given acid or base is strong or weak. If the dissociation is, for example, complete, that particular acid or base is strong. If the dissociation is somehow little or weak or partially dissociate, that particular term is what you call weak acid and weak base. Weak acid and weak base. The other important parameter to identify the strength of the acid is acid dissociation constant Ka and base dissociation constant Kb. So these are some terms to identify whether the acid is weak or strong. So generally what you call measurements of strength of the acid and bases in aqueous solution. Therefore, as I said in the earlier lesson, pH is minus logarithm of hydrogen ion or hydroxide ion concentration. So these are some of the acids and these are some of the bases. Okay. Therefore, based on this calculation, you can give whether the given acid or base is either strong or weak. These are the strength terms in general. Good. The second type of point is what we call percent ionization. For strong species, whether acid or base, if it is strong, their percent ionization is 100%. So the term we can say that this is strong acid or weak base. So this is the formula how can you deliver percent ionization. This is the formula. So these are some of the terms that supports percent ionization. So the percent ionized of weak base is equal to 1 over 1 plus 10 to the power of pH minus pKa. Ka stands for acid dissociation constant. Acid dissociation constant multiplied by 100. This generally gives the percent ionization formula for weak base. So the same trend is applied for weak acid. Instead of pKa, you can use pKb. The other important point to identify whether the acid or base is strong or not, what you call acid dissociation constant and base dissociation constant. Now first, let us begin from acid dissociation constant. What does it mean? This is a quantitative measure of the strength of an acid in the given solution. For example, in order to understand the acid dissociation constant, the acid must be weak first. When this weak acid reacts with water in a aqueous solution, that means hydrogen ion and their respective conjugated base is produced. So, in order to deliver acid dissociation constant, first, what will be the equilibrium constant expression for this reaction? Therefore, equilibrium constant expression is always the concentration of the product over the concentration of the reactant. As I said in the previous time, the concentration of pure liquid is always close to 1. Finally, the equilibrium concentration of this weak acid becomes concentration of the produced product H3O plus times concentration of conjugated base A minus divided by concentration of the acid itself. So the expression of this equilibrium constant is generally what you call acid dissociation constant. So here are the examples. So from the example, acetic acid is a good example of weak acid. So when this acid reacts with water, it produces hydrogen ion and its respective conjugated base. So what will be the representation of acid dissociation constant? It seems like this. Based on such kind of concept, you can at least force the weak acid reactions. So you can deliver the acid dissociation constant, and you can conclude that this is the expression of acid dissociation constant. Okay, so these are the second type of examples, the reaction between hydrochloric acid and water, of course. So when you dissolve hydrochloric acid in water, always there is production of hydrogen ion, rhenium ion, and conjugated base particle chloride. Of course, hydrochloric acid is a strong acid, while acetic acid is a weak acid. So for the dissociation constant of a strong acid is almost 100%. So we can apply this dissociation constant to understand the concept in weak acid rather than strong acid. These are the examples to understand acid dissociation constant. Assume that HA is the general expression for weak acid representations. So when this acid dissociates in water, it produces H plus, hydrogen ion and its conjugated base. So this is the way to deliver acid dissociation constant. Good. The second type is base dissociation constant. The only difference between base dissociation constant and acid dissociation constant is the second case, base dissociation constant. The reacting species are base, especially weak base. For acid dissociation constant, the reacting species are weak acid. That is the only difference. But the way to deliver and represent equilibrium constants are the same. Therefore, instead of Ka, you can use Kb. Base B stands for base dissociation constant. So by following the same principle as we understood from acid dissociation constant, this is a general expression for base dissociation constant, like this. But in order to express base dissociation constant, the base must be weak. The base dissociation constant for a strong base, once it is 100%. So we can apply this base dissociation constant on weak base. So this is the general formula. So when this base accepts a proton from the second species, especially from water, it produces hydroxide ion. It produces hydroxide ion. So the production of hydroxide ion indicates that this is base, especially weak base. So finally, by calculating base dissociation constant, now the strength of acid or base, it might be either strong or weak. You can judge based on this formula. Finally, when you combine these two dissociation constants in general, for example, when you multiply acid dissociation constant and base dissociation constant, self-ionization of water or water ionization constants are produced. These are very interesting formula, dear students. So the products of Kb and Ka always gives Kw. Kw is self-ionization of water. So this is the summary between weak acid and weak base. So these are some of the examples to understood base dissociation constants. So don't forget that always when hydroxide ion is produced, that particular term is Kb. When hydrogen ion is produced or H3O plus ion is produced, the dissociation constant is acid. So this is the only difference, but the way to deliver its numerical calculation is the same. So this is a good example, so you can practice. Good. So this is all about today's lesson. Now this is the summary point. Now let me remind some important aspects from this concept. From the first concept, Arrhenius, Bronsted and Lewis concepts are clearly discussed. So what is the main difference between these three concepts? How can you define acid and base based on their respective concepts? This is the first summary. And the second one is the strengths of acid and base. Based on pH and pOH, acid dissociation constant and base dissociation constant, and self-ionization of water, and even from the ionization of formula or from the ionization of acid and base, you can judge that the given acid or base is either strong or base. And the other important concept is dissociation constants, especially for acid. If weak acid reacts with water, always produces hydrogen ion. Finally, the equilibrium constant expression is generally what we call Ka, acid dissociation constant. When weak bases react with water, always hydroxide ion is produced. The representation of equilibrium constant is Kb. When you multiply Ka with Kb, always self-ionization of water, Kw is produced. So this is an important relationship. So this is all about the first lesson.